question is from GATE 2022, Mechanical Engineering Paper Set 2, question number 38. A linear elastic structure under plane stress condition is subjected to two sets of loading, 1 and 2. The resulting state of stress at a point corresponding to these two loadings are as shown in the figure below. If these two sets of loading are applied simultaneously, then the net normal component of stress, sigma xx, is dash. Let's find out. In the first case, we can clearly see that sigma xx will be equal to sigma for loading 1, but for loading 2, we will have to transform the stresses into x direction, because right now we know the stresses in x1, y1 directions. That is, sigma x1 is given as 0 because there is no stress in this direction, while sigma y1 is given to be sigma. So these two stress values has to be transformed into the xy plane. For doing that, we will use the transformation equation. So sigma xx only for the loading 2 case will be sigma x1 plus sigma y1 by 2 plus sigma x1 minus sigma y1 by 2 into cos 2 theta plus tau xy sin 2 theta. For the loading 2, we know that this is 0. There is no shear stress as well. Only stress acting is in y1 direction, which is sigma. So let's substitute that and find out sigma xx for loading 2 case. So here we have sigma by 2 plus this will be minus sigma by 2 into cos 2 times theta. Now theta is nothing but the angle that the rotated stress element is making with the coordinate axis along which we want to find the stress. So the angle that is made by x1 with x is our theta, which is nothing but 45 degree, but this is in clockwise direction. So we take it as minus 45 degree because anti-clockwise can be taken positive. So 2 into minus 45 degree, and this term is 0 already. So we only have these two terms here. Adding them together, we have sigma xx equal to sigma by 2 plus. Now this is minus sigma by 2 into cos minus 90. So cos 90 is 0, and therefore this second term also becomes 0. So we have sigma by 2 is the stress in x direction due to loading 2, and sigma is the stress in x direction due to loading 1. If we superimpose the two loadings, because we need to find out sigma xx for combined loading. So we write sigma xx when both loading 1 and 2 act simultaneously on the stress element is given as sigma plus sigma by 2, which is nothing but 2 plus 1, 3 sigma by 2. Let's go back and mark this correct option. Answer is in option A. 3 sigma by 2 is the net normal component of stress sigma xx if the two sets of loading are applied simultaneously. To learn more about analysis of stresses, you can refer to the NPTEL video Analysis of Stress 3. It is from the course Lecture Series on Strength of Materials. The course is taught by Professor S.K. Bhattacharya. He is from Department of Civil Engineering of IIT Kharagpur. I hope this solution helps you clear your doubt. Thank you.